My dear students, I think very well. Today we shall discuss the chapter on determinants. On behalf of Aptdemy, I, Dr. Vidyut Goravitya, just I will discuss the two problems for competitive purpose on determinants. And the details of the chapter is given on our e-learning platform. Those who have already registered, no problem, and our registration is going on, you may register yourself. Moreover, you can contact with the respective teachers on inline, online, and offline classes. And here's an announcement that on 11th June Sunday, we have arranged a free demo class on physics, chemistry, and mathematics from 9:30 to 5 p.m. at our Lake Town branch. So you may attend the classes in our, you may contact in our mail address. Now I shall start the problem on determinant. Problem number 1. Example 1. Let p and p plus 2 be prime numbers and let determinant delta is equal to factorial p plus 1, p plus 2, next factorial p plus 1, p plus 2, p plus 3, next factorial p plus 2, p plus 3, and p plus 4. Then the sum of the maximum values of alpha and beta such that p to the power alpha and p plus 2 whole to the power beta divide delta is you have to find out. Now first, you are given that the determinant delta is equal to, you are given delta equals to delta equals to factor determinant factorial p plus 1 factorial p plus 2 second row factorial p plus 1 factorial p plus 2 factorial p plus 3, and third row is our factorial p plus 2 factorial p plus 3 factorial p plus 4. Now look at the first row of the determinant. You can take common factorial p from the first row, factorial p plus 1 from the second row, factorial p plus 2 from the third row. So take common. So what you can write, factorial p into factorial p plus 1 into factorial p plus 2. So what you get, determinant 1, then p plus 1, then p plus 1 into p plus 2. For the second row, you have taken common, you have taken this factorial p plus 1. So this you can write as 1, next p plus 2, p plus 2 into p plus 3. Third row, 1, then p plus 3, next p plus 3 to p plus 4. Next step, here in the first column you have got 3 ones. So to make these two zeros, first apply this operation. This will apply. You can write this as apply the operation. First row is fixed. So you can write, here is our factorial p plus 1 and factorial p plus 2. R3 dash is equal to, here you can write R3 dash is equal to, that is third row changed, that is equal to R3 minus R2. Third row changed, R3 minus R2. So first row will remain the same, 1, then p plus 1, then p plus 1 into p plus 2. Second row is our 1, then p plus 2, p plus 2 into p plus 3. Third row minus second row. So this is our 0, and this is our 3 minus 2, that is our 1. And this minus this p plus 3 to p plus 4. Take common p plus 3. P plus 4 minus p minus 2. So this is our 2 into p plus 3. Next, to make it 0, so R2 dash is equal to this element 0. R2 dash is equal to apply the operation. R2 dash is equal to R2 minus R1. So apply this operation. R2 dash equals to R2 minus R1. So this will be equal to, first row will remain same, 1, then p plus 1, p plus 1, then p plus 1 into p plus 2, p plus 1 into p plus 2. Always this will remain the same. This is factorial p into factorial p plus 1 outside factorial p plus 2. R2 dash is equal to R2 minus R1. So this will be equal to 0. This minus this, so this will be equal to 1. And then this minus this, take common p plus 2, 2 into p plus 2. Third row equals 0, 1, 2 into 2 into p plus 3. After simplification, what you get? 2 into factorial p, expanding this p plus 1, factorial p plus 1 into factorial p plus 2. This you can write as 2 into factorial p, this whole cube, into p plus 1, as because factorial p plus 1 means factorial p into p plus 1. And here is our factorial p. This will be factorial p plus 2. This will be p plus 1 whole square. Since factorial p plus 1, this makes factorial p into p plus 1. And what is our factorial p plus 2? Factorial p plus 2. This means factorial p into p plus 1 into p plus 2. So here the sum of the maximum values of alpha and beta such that p to the power alpha into p plus 2 whole to the power beta. So what is our p to the power alpha means? This is our p to the power 3. It is the value of alpha will be equal to 3. If you compare this p plus 2 whole to the power 1, so what is the value of beta? Beta is equal to 1. So sum of the maximum values of alpha and beta. So alpha plus beta. So alpha plus beta, this is equal to 3 plus 1. This is equals to 4. This is our equalization p to the power 3 into something this, and because factorial p is out 1 2 c up to p. So power of p plus 2 whole to the power 1, so the value of beta is 1 and value of alpha is 3. So alpha plus beta equals to 4. So the maximum values of alpha and beta such that p to the power alpha into p plus 2 whole to the power beta is 4. So the answer will be 4. And coming to the second problem on determinant, if x, y, z are in alphabetic progression with common difference d and x not equal to 3, and then the determinant of the matrix 3 4 5 4 2 5 2 k x y z is 0, you are given that the determinant of the matrix is 0, then what will be the value of k square? You are given the 4 options. So first, note that x, y, z are in a Z with common difference d. That means you can write common, as the common difference is d, you can write y is equal to y is equal to x plus d, z equal to x plus 2d. That is x plus d, x plus 2d. X, y, z are in AP with common difference d. Therefore, you can write y is equal to x plus d and z equal to x plus 2d. Now, what you are given? Determinant of the matrix is 0. Given determinant of the matrix, so determinant sign 3, 4, 5. Then you can write 4 root 2, 4 root 2, 5 root 2, k, x. In place of y, we can write x plus d. In place of z, you can write x plus 2d. So this determinant equal to 0. Now we simplify it. Here you are given in this column x, x plus d, x plus 2d. Apply this operation. What is the operation? There is R2 dash. The second term changed. There is R2 dash. You can write this is equal to R2 minus R1. Apply this operation. And R3 dash is equal to R3 minus R1. What do you get? So first row will remain unchanged, that is 3, 4 root 2 and x. Second row minus first row, 4 minus 3, this is our 1. 5 root 2 minus 4 root 2, that is our root 2. X plus d minus x, that is our d. Next, 5 minus 3, this is our 2. Then k minus 4 root 2, x plus 2d minus x, 2d. Now, to make this element 0, what will be the operations? You multiply this by 2 and subtract with the 2d. That means multiply the second row by 2, that is third row will be changed as R3 dash is the value you can write. R3 dash, apply this operation, R3 minus 2R2. R3 minus 2R2. Why apply this operation? This element will be 0 and this element will be now apply this operation. So the first row will remain the same, 3, 4, 2, and then x 1 root 2 d. This is equal to 0, so you can write this equals to 0. And next, multiply this by 2 and subtract this will be 0. R3 minus 2R2, that is k minus 6 root 2. And this is also 0. So this will imply determinant of this equal to 0. This is an increment sign, and this will be equal to 0. Now we expand the two elements of the third row is 0. So expand this determinant with respect to the third row. So expanding with respect to the third row, what will get? We will get k minus 62. If you expand it, minus of this 3d minus x, 3d minus x equals to 0. So this will imply k is equal to 6 root 2 and 3d equal to x. But it is given that, given 3d not equal to x, x not equal to 3d. So we will get the value of k is equal to, therefore you can write k is equal to 6 to 2. Now what do you want? We want the value of k square. Therefore, k square equals to 72. So the correct option is, therefore, the correct option is A. So the correct option is a very interesting problem. The x, y data in a with common difference d. So at once you can write y is equal to x plus d, z equal to x plus 2d. Now you are given that the determinant of this matrix is 0. So put here determinant of this equal to 0. Now here in the third column, look at x, x plus d, x plus 2d. So in terms of the first row, you can subtract the first row from the second one and the third one also. So we have done this R2 dash equal to R2 minus R1 and R3 dash is equal to R3 minus R1. What you have got? This equal to this determinant equals to 0. And expanding with respect to the third row, you have got k is equal to 6 to 2 and 3d equal to x. But you are given that x not equal to 3d, so we can at once write k is equal to 6 to 2. Therefore, k square equal to 72. So the correct option is 1a. So the correct option is A. Thank you.